Find dy by dx of the function cos of x whole to the power of y is equal to cos of y whole to the power of x. So as you can see, it is an explicit function. So we have, sorry, implicit function. So we have a weird expression, right, at both ends. So we can apply log at both ends and differentiate it and then solve for y prime that is. Or we can, as usual, call each of this term with a new variable name, cos of x whole to the power of y, and v to be cos of y whole to the power of x. So from this we can tell that u is equal to v. So that's a pretty good, equation to know, because when things come to cancel, we will be able to cancel easily. Now, if I differentiate both the left hand side and right hand side with respect to x, differentiate with respect to x, we have this following equation. Now, our job is to find u prime and v prime. Cos of x whole to the power of y, and we take log on both the sides. So we have log of u is equal to y times of log of cos of x. Now, differentiating both with respect to x. So we have u prime by u is equal to, clearly this is a product rule. So first is your dy by dx, so that is y prime, into log of cos of x, plus you have y into differentiation of log of cos of x. Now this we can differentiate. So differentiation of log of cos of x would be doing it here itself, because I would like you guys to get used to the idea. And as per the chain rule, again we have to differentiate cos of x. That would be minus sine of x. So finally you have u prime, which is equal to u times of y prime. Then we have log of cos x. Then we have minus u into y into tan of x. So that is your u prime, right? Then we have v, which is equal to cos of y whole to the power of x. Now, if I take log on both the sides, taking so I end up with log of v is equal to x times of log of cos of y. So again differentiating with respect to x. So we have v prime by v is equal to log of cos y plus x by cos y, right? So what is that I am doing? I differentiated x with respect to x in the first place, and I multiplied with the second term. Then I kept the first term and differentiate the second term. Log of anything is 1 by cos, and as per chain rule I need to differentiate cos also. So this would be minus sine y. Please learn the chain rule and apply it in a single line. Get to that point as soon as possible. Now we have v that I need to multiply, and this expression turns out to be x into tan of y. Right, finally, as u prime is equal to v prime, I can equate my, where is it? Yeah, that's my u prime. I can equate it to, not that, this expression. Now we know that v is equal to u, right? So in all of this we have v and u. So that I can cancel it off. Reason as v or u is equal to v. Okay, and then this is a bit of rearrangement. I missed one thing. Differentiation of here, you need to have y prime. Differentiation of sine y as per chain rule will be, sorry, cos y is minus sine y into y prime. So I missed that. So you need to have y prime there. And now finally a bit of rearrangement. All the y prime I'm getting on the left hand side, y prime into log cos of x plus tan x y prime. So both these terms have y prime as a common term. So I can take it common. And on the right hand side I'll get all the constants. So log of cos y plus y times of tan of x. And finally we have y prime is equal to log cos y plus y into this entire expression divided with log cos of x, all these are in brackets, remember, plus x into tan of y. Yeah, that would be your final expression. See, the point is I kept in mind that u is equal to v, and that's why I didn't substitute. I knew it will cancel. Right? We have seen enough problem to see that things will get cancelled. Even if you substitute, you should keep in mind that those terms will get cancelled.